This is Judy Heights, and this is the Science Screencast. This screencast is about glucose and cellular respiration. Glucose is an important molecule. It's a sugar, and it's a simple carbohydrate. We'll talk more about that later, but there are a couple of important things you need to know about glucose before we talk about cellular respiration. Glucose is a molecule that is constructed from 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. When these atoms bond together, they create a molecule glucose, and it often forms a ring structure like this. The blue dot represents carbon, and there are 6 carbons in glucose, 1, 2, 3, 4, 5, 6. The red dot represents oxygen. The chemical formula for glucose is C6H12O6, and this represents 1 glucose molecule. The ring structure is called a carbon skeleton. It doesn't show you where all the hydrogens and oxygen atoms are. It only shows you the carbon atoms. So where are all the hydrogen and oxygen atoms anyway? Carbon atoms in glucose are not only bonded to another carbon atom, but since each carbon can form 4 bonds, they can also bond to hydrogen, the H, or a hydroxyl group, the OH. So if you look at the glucose molecule here on the right, you'll see that each carbon is bonded to hydrogens or hydroxyls. And if you count up all the atoms in this molecule, you'll see that it has 6 carbons, 12 hydrogens, and 6 oxygens. This molecule picture is a little bit harder to draw and a little bit harder to see than the ring structure. So the ring structure is really kind of a shorthand for this molecule. Now, glucose is an organic molecule. Organic molecules are molecules that have carbon-hydrogen bonds. And carbon-hydrogen bonds are very important in cellular respiration. But why are we so concerned about carbon-hydrogen bonds? Well, it turns out that there's lots of energy in glucose, and living organisms can extract energy from carbon-hydrogen bonds. And because of all the carbon-hydrogen bonds in glucose, glucose has lots of energy. Cellular respiration is the name we give to the process by which aerobic organisms, meaning those organisms that can use oxygen, can get energy out of glucose and turn it into ATP. The energy in glucose is not in a form that living things can use directly. It has to be converted into the molecule ATP to be usable by cells. More about ATP later, but think about it this way. If you have a gold nugget and you go to McDonald's to buy lunch, the servers at the restaurant will not accept it even if it's worth far more than your French fries. The gold nugget is not a form of money the restaurant can use, but if you take your gold nugget to a geologist who gives you dollar bills for your gold nugget, you'll be able to buy lunch. Even though glucose contains lots of energy, that energy is useless to the cells unless it's converted into the dollar bills of cellular energy, ATP. So, cellular respiration is the process by which aerobic organisms break down glucose to get energy out. The overall reaction for cellular respiration is glucose plus oxygen reacts to create carbon dioxide and water. The term overall reaction means this reaction is a summary. In reality, there's many other molecules involved in the process, but the summary of the reactions is where glucose reacts with oxygen and creates carbon dioxide and water, and this results in the release of energy.